Next, we're going to review how scan can be used to interrogate some of the RPG algorithms. So let's go ahead and go to WFO scale, and we will go to the scan menu. We're going to go down to the bottom, and we're going to look for the scan storm cell site storm threat. When that comes up, we will go to the KCRI menu and load Z SRM8 0.5 degrees to have a little bit of base data underneath it. When the scan storm cell table comes up, this is similar to other tables like FFmpeg where we can sort by left clicking on the column. So let's left click on the H size column. It turns purple and ranks things by hail. We can left click again and it reverse sorts. So we left click on a column header to rank by that attribute. Then that's a 2.25 inch maximum expected hail size from the hail algorithm. And we can click on the SCIT cell ID K3 and it will zoom in on that cell. Let's go ahead and right click on the scan storm cell display text, and we will change the width to 3 pixels so that we can kind of see this a little bit better. Let's toggle over to reflectivity using the dot key on the keypad. And we can do a Control-I to get the imaging properties up and then reduce the brightness so that we can kind of see both the image and the overlay. Okay, so we have a hexagon in here that has all these attributes with it, and we can click over here on any of the other storms in the cell table. But just focusing on K3, it's this one right here. If we left click, it zooms on that cell ID. If we right click on it, then we can see the trend graph comes up, and we can see a quick kind of summary of the algorithm. As long as it's tracked, the RPG has tracked the cell, then there'll be a lot of reflectivity based attributes like max reflectivity are up in the mid 60s. The cell-based VIL is increasing from 70 to 90 over the last few volume scans, and the maximum expected hail size has consistently been over 2 inches. So also the storm top down here, it has these little lines for each volume scan, so you can see the sampling and how it gets affected by these observations at different tilts. But the basic quick look is you can have a sense for not only what does the RPG say is going on now, but what's the history been of some of these storm cells. If we wanted to do just a quick look at just the hail size trend, we could left click on that box of 2.25 and up will pop up the cell trend graph for that box. So that's just a quick kind of introduction to the main interface here. We see that there is a little bit of mesos information in here with the strength rank of 5. That's that kind of moderate rotation, at least as far as the 3D strength rank is concerned. If we want to look into more detail at the mesocyclone attributes, we can launch the meso table from the tables here. And then we can look at cell K3 right here. And that has a maximum rotational velocity of 43 knots and the low-level rotational velocity of 17. So at least as far as the algorithm is concerned, there's mainly mid-level rotation with that. If we check the actual base data, we see it's got strong convergent flow down low, so there might be a little bit to that, but the algorithm information for this particular radar is really noisy for the DMD for some reason right now. If we were to go into the tables and look at the TVS table, since there is a TVS, then we can look at the TDA algorithm output. Low-level delta V of 160 knots is strong, so TDA is fired on it. Even though the meso has not, but it could be getting confused with a number of these different circulations with this neighboring storm nearby. So we have reviewed the cell table, a lot of the attributes, the probability of large hail, severe weather. All these scan algorithms all are unusually low and don't appear to be working in this case review. So that's another thing we caution against using. The main parameters that are worth looking at for the RPG on a on a routine basis. The hail size, the maximum expected hail size from the 880 algorithm, although it has biases, can have some signal and give you another perspective on potential hail size. Whether any of the DMD attributes in TVS are in there, that's maybe some of the more significant attributes that can be looked at. The other thing that scan can do is you can have an unwarned polygon where you can set up, like I can make an unwarned tornado for any TVS, which is, there's lots of TVSs that don't produce tornadoes, so that's not necessarily a good idea, but you could do this for unwarned severe for hail, let's say of golf ball size or something where it has a little bit more of a track record that if you if there was a detection that wasn't in a polygon, then it would let you know. So we'll do this for TVS. There's a little pop-up alert viz alert error message with that, which I'm not sure why, but that's not important. The main thing is if you configure the unwarned county, or unwarned polygon I should say, then the identification gets highlighted if there's no warning, so there's no tornado warning for these TVS detections. So we're not going to go into details of this case and why the I think the tornado warning is farther east with the other supercell, and so we're not going to go into that, but at least you can kind of see that if you wanted to configure scan to be a safety net for, do you have algorithm attributes that you trust, that if they get exceeded and there's no warning out, would you want to highlight it in the table? So there's all sorts of control over the colors and the alerting. You can have pop-ups and sounds for algorithm thresholds getting exceeded. But the algorithms have a lot of issues with it. It's a safety net with holes, so most people have all the alarms and things turned off from scan. And some of the easier things to get from it are going to be just the trends of the maximum expected hail size from the RPG, as well as some of the reflectivity and maybe some of the velocity attributes from the meso tables.